the Earth is 4.5 billion years old. Researchers believe that Earth may have reached a stage where life may have flourished around 4.3 billion years ago. Even still, the earliest fossils that have been discovered date back just 3.7 billion years. It's possible that life once flourished throughout that 600 million year period before being wiped out in violent collisions with comets and asteroids. The emergence of both heritable and evolvable self-reproduction is considered the origin of life, which means life began as simple molecules that were already functional, and natural selection and cooperation drove its slow evolution towards greater complexity. Two possibilities are in volcanically active hydrothermal environments on land and at sea. Some microorganisms thrive in the scalding, highly acidic hot springs environments like those found today in Iceland, Norway and Yellowstone National Park. The same goes for deep-sea hydrothermal vents. These chimney-like vents form where seawater comes into contact with magma on the ocean floor, resulting in streams of superheated plumes. The microorganisms that live near such plumes have led some scientists to suggest them as the birthplaces of Earth's first life forms. Organic molecules may also have formed in certain types of clay minerals that could have offered favorable conditions for protection and preservation. This could have happened on Earth during its early history, or on comets and asteroids that later brought them to Earth in collisions, and the same process could have seeded life on planets elsewhere in the universe. The ingredients include water, organic substances, and a consistent energy source. Photosynthesis is fueled by the energy source at the surface, which is sunlight. Geothermal energy provides the chemical fertilizers necessary for life on the ocean floor. The components essential to existence are also vital. These are, in our case, nitrogen, phosphorus, oxygen, hydrogen, and carbon. However, there are a number of unanswered scientific questions regarding how these elements came to be on Earth. For instance, it is surprising to scientists that a planet formed so near to the Sun would naturally have nitrogen and carbon. These elements don't solidify closer to the Sun, where Earth is, but only at extremely low temperatures, as those found in the outer solar system. This is because carbon forms chemical bonds with iron more frequently than with rock. The majority of gold gets up in the Earth's core because it binds with metal more frequently. The final component is water. Approximately 70% of the Earth's surface is covered with water today, but how much was there 4 billion years ago? Water is considerably more likely, along with carbon and nitrogen, to end up in solid objects that developed farther away from the Sun. According to one idea, a class of meteorites known as carbonaceous chondrites developed sufficiently far from the Sun to have functioned as a water delivery system, which would account for its presence on Earth. 1. Abiogenesis, chemical evolution theory. Abiogenesis is a scientific term for the natural process by which life arises from non-living matter. This theory proposes that life originated from simple organic molecules through a series of chemical reactions in the early Earth's environment. Key components of the abiogenesis theory include as below. Primordial soup hypothesis, proposed by scientists like Alexander Oprin and J.B.S. Haldane. This hypothesis suggests that the early Earth's atmosphere and oceans contained a primordial soup of organic molecules, including amino acids, nucleotides, and sugars. These molecules formed through reactions involving gases like methane, ammonia, water vapor, and hydrogen. 2. RNA World Hypothesis. It proposes that RNA, ribonucleic acid, played a central role in the early evolution of life on Earth. According to this hypothesis, RNA is capable of both storing genetic information and catalyzing chemical reactions, making the first self-replicating molecule. Scientists have demonstrated that the building blocks of RNA can be synthesized under prebiotic conditions, which confirms that RNA could have formed spontaneously on the Earth. Transition to DNA-based life. Over time, RNA-based life forms could have evolved mechanisms for more stable and efficient information storage, leading to the emergence of DNA-based life. This transition may have occurred through the development of protein enzymes that could replicate DNA. Key facts about the origin of life on Earth. 1. Earliest evidence. The oldest direct evidence of life on Earth comes from fossilized microorganisms called stromatolites, which date back over 3.4 billion years. 2. Complexity of life. Life on Earth has evolved from simple single-celled organisms to the vast diversity of life forms we see today. This process of evolution through natural selection has led to the emergence of complex organisms, including plants, animals, and humans. 3. Role of extremophiles. Extremophiles are organisms that thrive in extreme environments such as hot springs, deep-sea hydrothermal vents, and acidic lakes. Studying extremophiles helps scientists understand the conditions under which life could have originated on Earth and potentially on other planets or moons in the universe. 4. Extraterrestrial life. The study of the origin of life on Earth has implications for the search for life elsewhere in the universe. Scientists explore environments on other planets and moons, such as Mars and Europa, that may harbor conditions conducive to life or have evidence of past life. The origin of life remains an active area of research, with scientists conducting experiments, simulations, and field studies to test various hypotheses and advance our understanding of life's beginnings.